The next features that we are going to cover is the features of handover. This is the overview of the mobility management in the LTE eUtron, where the users could be in idle state or connected state. And we have covered the mobility management of idle state, which is called cell reselection earlier. Now, the focus of this chapter is the mobility management for the user in connected state, where there are two methodology to move a user from one network to another network or from one cell to another cell, which it could be handover or redirection. The difference between the handover and redirection simply by handover, it means the eUtron is going to send a handover request to the target cell or the target system with the help of the core network, and the RRC of the user or the UE context of the user will be released only after the handover has been executed successfully. And as to compare with handover, redirection does not involve the signaling exchange between the source cell and the target cell, where the user will be having RRC released straight away by the eUtron right after the redirection decision is made. So for handover, there are three types of handover, which the first two belong to intra-LTE handover, which it could be intra-frequency and inter-frequency handover, and eventually IRAD handover, where it could be the handover to 3G or GSM or CDMA 2000. So for this course, we are going to cover intra-LTE handover, which include intra-frequency and inter-frequency handover. So these are the procedures of the handover with the entities involved, where it starts from UE measurement. So the user has to measure the target frequency or the target cell signal. Of course, that depends on the UE capability. So some of the terminals, they are not able to measure the signal strength of another system. So that UE measurement, it really depends on the UE capability as well. Then after the user perform the measurement on the candidate cells, then the user are reporting to the eNodeB, where the measurement handling, it depends on what are the factors which trigger the handover. The factors triggering the handover are various, where the most common factors is coverage-based handover. So different type of the triggering factor, it might induce some difference of the measurement as well. So we are going to have a look on the details of this in the next few pages. When a user is required to perform measurement, and if it is intra-frequency handover, the user do not need to enter a measurement gap. But what if the user is required to measure the signal strength of another frequency? So any inter-frequency or IRAD measurement requires a measurement gap to be provided that is under gap pattern control. And some of the SON feature, which include MRO, Mobility Robustness Optimization feature, it helps to automatically adjust the handover parameters. And the neighbor cell management, to decide how many neighbor cells could be configured in the system and how many neighbor cells to be included in the measurement control. So all of these are also part of the handover procedure. So based on the measurement report sent by the user, then the eNodeB decide on the handover, and that will be done after the candidate cells filtering. So we can see here there is a possibility of the blind handover to be performed. That depends on the switches and the threshold that we are going to set for some of the blind handover. After the decision, then the source cell is going to send handover request to the target cell or the target system, followed by the handover execution. So we have seen earlier that there are a lot of factors triggering handover. Number one, that is the most common handover type, which is coverage-based handover. Coverage-based handover is triggered because the user is moving out from the coverage of the source cell, and that could be performed, could be solved by performing intra-frequency handover or inter-frequency and IRET handover. So for intra-frequency handover, there is no measurement gap required for user to start measuring, where the user perform intra-frequency measurements by default based on the instruction included in a message, which is called measurement configuration. So user receive measurement configuration right after a radio barrier has been established. So the user will measure intra-frequency neighbors all the time. In contrast, if the user has to measure inter-frequency and IRET neighbor, then the eNodeB has to deliver the relevant measurement configuration to the user with a criteria, where the criteria would be the signal quality of the serving cell is lower than the associated threshold. So that is the triggering point for inter-frequency or IRET measurement for coverage-based handover. The next category of handover is called frequency priority-based handover. And that is only possible for inter-frequency handover, where the user is required to perform handover simply because the frequency priority has been set to be higher. So the neighbor frequency has been set with higher priority, where then the user has to send event A1 report in order to trigger the measurement of the higher priority frequency layer. The third handover type is called service-based handover. And again, this is only viable through inter-frequency or IRET handover. So if you look at the name, we should know that the handover is being triggered because the service which is implemented by the user is a special service, which usually it represents a voice service, which is VoLTE. So this is suitable for the operators if they wish to carry VoLTE on a specific frequency layer in LTE, or if you want to move that to 3G. Uplink service quality-based handover is triggered by the poor uplink radio link, where the detection is based on the uplink transmit power and the block error rate and even the number of the retransmission. So again, that is also not including intra-frequency handover. So only inter-frequency or IRET handover is possible. And lastly, distance-based handover. That is being triggered by the eNodeB. If the eNodeB detected that the distance between the user and the eNodeB has been greater than a threshold, then the user is required to perform handover to inter-frequency neighbor or IRET neighbor. So this is the measurement control information, which it is a set of the measurement instruction and the handover reporting instruction. So they are all set in the eNodeB and sent to the user via RRC reconfiguration message. So this message includes the measurement configuration, which include measurement object, report configuration, measurement ID, and filter coefficient configuration. So if the measurement configuration is meant for inter-frequency or IRET measurement, then there is one additional information, which is measurement gap configuration. That is for gap-assisted measurement. So we have seen earlier that there are three main components in the RRC configuration, including the object, report, and measurement ID. So the first information is about the object. So object is all about the information of the neighbor frequency. So it starts from the downlink EARFCN, which is the downlink, the evolved absolute radio frequency carrier number. So this is used to indicate the downlink frequency number of the particular frequency layer. Measurement bandwidth. So this is to tell the user the bandwidth that the user has to measure if before performing the handover. So the number of the resource block which is required to be measured by the user on that particular frequency. Q offset frequency. This indicates the frequency offset of one particular interfrequency neighboring cell. So this is again per frequency. Neighbor cell configuration. That is to inform the users that are all of the neighbors of that particular frequency, are all of them having the same TDD configuration or not. So this is specifically used for LTE TDD. Are they having the same subframe configuration or not? Presence antenna port 1. This is to inform whether all of the neighboring cells of that particular frequency are configured with double transmitter antenna or not. High priority neighbor list. Now only the neighbor cells with high measurement priority will be included in the measurement configuration. So not all of the neighbors which have been considered in the system will be included in the measurement object. Only the neighbors with high measurement priority will be included in this measurement object. The second important information included in the measurement config is all about the report configuration. So the event report trigger reporting mode is used in the LTE handover, where it starts from event A1. Event A1, it indicates that the signal quality in the serving cell is higher than a specific threshold. That is usually used to stop the measurement gap. In contrast, event A2 is sent by the user to tell the inert bit that the signal quality of the serving cell is lower than the threshold, means the user wishes to start a measurement gap. Event A3 indicates that there is at least one intra-frequency or interfrequency neighbor cell is with a RSRP or RSRQ greater or higher than that in the serving cell. So the neighbor signal is greater than the serving signal. That is the conclusion or the summary of event A3. And event A3 is a mandatory event to be used for coverage-based intra-frequency handover. Event A3 could be used for coverage-based inter-frequency handover as well. Event A4 indicates that the signal quality of one interfrequency neighbor is greater than a specific threshold. So as compared with event A3, event A4 does not compare the neighbor with the serving cell, but instead event A4 simply compare the signal of the neighboring cell with a specific threshold. Event A5, that is the event A2 plus A4, that means event A5 simply means the serving cell signal quality is worse than a threshold, and the signal quality of a neighbor, interfrequency neighbor cell, is greater than a specific threshold. So A5 is more strict compared to A4, but they are all used in the similar handover type. Event B1 is similar to event A4, but that is for IRAD handover. Event A2 is the same with event A5, but again, this is for IRAD handover. In the measurement config, if the measurement configuration is meant for interfrequency or IRAD measurement, then the configuration of measurement gap has to be included. Measurement gap allows the user to measure the signal strength of another frequency during the gap time. So the user will be repeating the gap time after T period, where the T period could be 40 millisecond or 80 millisecond. So during the gap time, the user is actually staying in the current frequency for some time, where the user is going to measure, is performing the measurement during the gap time. So the gap is actually time for actual measurement is actually smaller than the gap time, and the gap time it lasts for 6 milliseconds. So the user measure the other frequency for 6 milliseconds, and it's going to be repeated every 40 millisecond or 80 millisecond depending on the measurement gap configuration.